In this video, I will show you how to solve basic trig equations like this one. We will limit our solutions to the interval between 0 and 2 pi. That's one time around the unit circle. Throughout this video, I will be assuming that you have memorized all of the values on this chart. For example, the cosine of pi over 6 is radical 3 over 2. You should know that off the top of your head. So let's get started. First, we need to get cosine by itself. Adding 1 to both sides, we have 2 cosine x is equal to 1. Dividing both sides by 2, we have cosine x is equal to 1/2. What is the reference angle? You should be asking yourself the cosine of what angle is equal to 1/2. The reference angle is pi over 3. I'm getting that right off the chart here. The cosine of pi over 3 is 1/2. There are 4 angles that have a reference angle of pi over 3. There's 1 in each quadrant. Because the reference angle is pi over 3, I am going to think of pi as 3 pi over 3. I will think of 2 pi as 6 pi over 3. That makes this angle 2 pi over 3, and this angle is 4 pi over 3. And this angle is 5 pi over 3. Of course, in the first quadrant, you have just the reference angle, pi over 3. The cosine of any of these angles is going to be some kind of 1/2. It's just that cosine is positive on the right-hand side. So it's going to be positive here and here. Cosine will be negative here and here. Since we want cosine to equal positive 1/2, the solutions will be pi over 3 and 5 pi over 3. So x is equal to pi over 3 and 5 pi over 3. So problem number 1 has 2 solutions. Notice that if this had been cosine x equals negative 1/2, the solutions would have been 2 pi over 3 and 4 pi over 3. Jumping over to problem number 2. Let's start by getting sine theta by itself. Adding 1 to both sides, we have radical 2 sine theta is equal to 1. Dividing both sides by radical 2, we have sine theta is equal to 1 over radical 2. Again, we ask ourselves, what is the reference angle? Hopefully, you're thinking the reference angle is pi over 4. Where's that chart? The sine of pi over 4 is 1 over radical 2. There are 4 angles that have a reference angle of pi over 4. There's 1 in every quadrant. Because the reference angle is pi over 4, I'm going to think of pi as 4 pi over 4. And I will think of 2 pi as 8 pi over 4. That makes this angle 3 pi over 4. And this angle is 5 pi over 4. And this angle is 7 pi over 4. The first quadrant is the reference angle itself of pi over 4. The sine of any of these 4 angles will be some type of 1 over radical 2. It's just that I will have a positive 1 over radical 2 in the first quadrant and the second quadrant, where the sine function is positive, because sine is a y value. I will get negative 1 over radical 2 in the fourth quadrant and in the third quadrant. Since I want positive 1 over radical 2, the solutions will be pi over 4 and 3 pi over 4. All right, for problem number 3, let's get cotangent by itself. We will add radical 3 to both sides, and we will have cotangent x is equal to radical 3. We are less familiar with cotangent and more familiar with tangent. So let's take the reciprocal of both sides of this equation. The reciprocal of cotangent is tangent. The reciprocal of radical 3 is 1 over radical 3. What is the reference angle for this problem? This is going to be pi over 6. You should be asking yourself, the tangent of what angle is 1 over radical 3? And if you have this chart memorized, you know that the tangent of pi over 6 is 1 over radical 3. That's why the reference angle is pi over 6. There are 4 angles that have a reference angle of pi over 6. There's one in every quadrant. With a reference angle of pi over 6, I'm going to think of this as 6 pi over 6, and I will think of this as 12 pi over 6. That means that this angle is 5 pi over 6, and this will be 7 pi over 6, and this will be 11 pi over 6. And of course, in the first quadrant, it's just pi over 6. The tangent of any one of these 4 angles will be some type of 1 over radical 3. It's just that in the first quadrant and the third quadrant, I'm going to have a positive 1 over radical 3. Tangent is positive in these 2 quadrants. In the second quadrant and the fourth quadrant, I will have a negative 1 over radical 3. Tangent is negative in these 2 quadrants. Since we want tangent of x to equal positive 1 over radical 3, the solutions are pi over 6 and 7 pi over 6. So these are the 2 solutions for problem number 3. Okay, this one has a new twist. It is squared, so we will have to deal with that. But let's start by adding 1 to both sides. That will give us cosine squared theta is equal to 1. Next, we need to take the square root of both sides. I think I'll show it just this once. I want to unsquare this and leave this as just a plain old cosine. But to unsquare things, we use the square root. Please don't forget that whenever you take the square root of both sides of an equation, the solution can be positive or negative. So now we have cosine theta equals plus or minus 1. So this is where I would normally say, what is the reference angle? But actually, this is a quadrantal angle situation, so there is no reference angle. Here's what I mean. Over here on the right-hand side, the coordinates are 1, 0. At the top, 0, 1. On the left, negative 1, 0. At the bottom, 0, negative 1. Remember that cosine is the x value on the unit circle. We want the cosine, the x value, to be positive 1 or negative 1. So here's a positive 1 x value, here's a negative 1. So both of these will give me solutions. So that means theta is equal to 0 radians right here, and pi radians over here. So these are the 2 solutions for problem number 4. Okay, this one's also squared, so ultimately we will have to take the square root. Let's start by dividing both sides by 4. We will then get sine squared x is equal to 1/4. Now we need to take the square root of both sides to unsquare this, and the solution will be plus or minus, don't forget. Some students have trouble with this. Please understand that if you take the square root of a fraction, that's the same thing as taking the square root of the numerator and denominator separately. So I'm going to get sine x, all right, we took the square root, so it's not squared anymore, is equal to plus or minus. Now the square root of 1 is just 1. The square root of 4 is 2. So we have plus or minus 1/2. What is the reference angle going to be? Hopefully you were thinking pi over 6. The sine of what angle is 1/2? If you have your chart memorized, you know that the sine of pi over 6 is 1/2. That's why the reference angle is pi over 6. There are 4 angles that have a reference angle of pi over 6. There's one in each quadrant. Since the reference angle is pi over 6, I am going to think of pi as 6 pi over 6, and I will think of 2 pi as 12 pi over 6. That makes this 5 pi over 6, and I have 7 pi over 6 here, and 11 pi over 6 right here. And this is just pi over 6 in the first quadrant. The sine of any of these 4 angles will be some type of 1/2. It's just that I will have a positive 1/2 in these 2 quadrants, where sine is positive, and I will get a negative 1/2 in these 2 quadrants, where sine is negative. Well, we want the sine of x to be positive 1/2 or negative 1/2. So we want all 4 of these solutions. So x will equal pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. All the pi over 6's. All right. And problem number 6. Let's start by adding 1 to both sides. That will give us 3 tangent squared x is equal to 1. Dividing both sides by 3, we get tangent squared x is equal to 1/3. Time to take the square root of both sides. So we will have tangent x equals plus or minus. Don't forget, when you take the square root of both sides, the solution will be positive or negative. And the square root of 1 is just 1. The square root of 3 is just the square root of 3. So tangent x is equal to plus or minus 1 over radical 3. What is the reference angle in this situation? Hopefully you were thinking the reference angle is pi over 6. How did I know that? Because I have memorized my chart. You should be asking yourself, the tangent of what angle is 1 over radical 3? Okay, the tangent of pi over 6 is 1 over radical 3. That's why the reference angle is pi over 6. There are 4 angles where the reference angle is pi over 6. There's one in every quadrant. Because the reference angle is pi over 6, I will think of pi as 6 pi over 6, and I will think of 2 pi as 12 pi over 6. That makes this 5 pi over 6, and this is 7 pi over 6, and this is 11 pi over 6, and this is just pi over 6. The tangent of any of these 4 angles will be some type of 1 over radical 3. But it will be positive 1 over radical 3 here and here. Tangent is positive in the first quadrant and the third quadrant. I will get negative 1 over radical 3 here and here, because tangent is negative in the second quadrant and the fourth quadrant. For this problem, we want tangent of x to be positive 1 over radical 3 or negative 1 over radical 3. So all four of these will be solutions. So the solutions are pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. And that's how you solve basic trig equations.